This is the video for geometry lesson 1.7, midpoint and distance in the coordinate plane. So we're going to start with midpoint of a segment. So to find that, we can use, there's actually two formulas, one on a number line and one for in a coordinate plane. So starting with the midpoint formula on a number line, if you have a number line where you have two coordinates, little a and little b, and you're trying to find what is the coordinate of that midpoint, it's just going to be the average of those two coordinates of your endpoints. So it's just going to be a plus b divided by 2. Here. It's just the average of the two endpoints. And then in a coordinate plane, it's going to be a little bit more complicated, but not too bad, right? In the coordinate plane, there are two coordinates, an x-coordinate and a y-coordinate. If you have an endpoint with an x and y coordinate at one endpoint and another x and y coordinate at the other point, the coordinates of the midpoint are just going to be the average. The first coordinate is going to be the average of your x coordinates, and then the second coordinate point is going to be the average of your y coordinates. So actually, not too bad. Let's see this in action on the slide. Okay. So finding the midpoint. So here we have a number line. We have one endpoint on -4. We have one endpoint on 9. So what's the coordinate of this midpoint? We just take the average. So -4 plus 9 divided by 2. That's 5 divided by 2, which is 2.5. So the midpoint here would be, if this is 3, it's going to be something like this. This is where my midpoint would be. Right, and you can check it by counting in this case because we can see it, right? This is 1, 2, 3, 4, 5, 6.5. 1, 2, 3, 4, 5, 6. 6.5. There we go. So that's right. Okay, and then on the coordinate plane, this example we have one endpoint at 2, -4, one endpoint at 7, 5. So in order to find the midpoint here, we're going to take the average of our x's, so 2 plus 7 divided by 2, and then the average of our y's, here's -4 and 5, -4 plus 5 divided by 2. So that's going to be our coordinate. And then we can just solve for that. 7 plus 2 is 9. -4 plus 5 is 1. So this is going to be at 4.5, 0.5. And we can look at that here. 4.5, 0.5. Looks like it's about there. And that would be your answer. Okay, so try this on your own using the formulas. JK has endpoints at -12 and 4 on a number line. What's the coordinate of its midpoint? So push pause, try this on your own, and then come back to check your answer. Okay, and here we go. We have -4. Hopefully you got -4. Okay, moving on to you guys can try your own, find the midpoint with on a coordinate plane. Okay, so here you have a midpoint with endpoints at R and S. Find the coordinates of your midpoint. So push pause, try this on your own, and then check back for the answer. Okay, hopefully you tried that and you got 4, -2. If not, come with questions or pause and look at my solution. See if you can find what you did wrong. Okay, next problem. So this is going to be finding an endpoint. So we're going to basically be backing into one of these numbers, or one of these points, given the midpoint. Okay, so we're going to just do this a little backwards. So this is saying, okay, say you know that the midpoint is -2, 1, and you know that one of the endpoints is -5, 7. What's the other endpoint? So let's call the other endpoint xy, right? And then we're just going to solve for xy. So if we know these are the two endpoints, right, to find the midpoint, we would do -5 plus x divided by 2 and 7 plus y divided by 2, right? Because this midpoint here is going to be the average of -5 and whatever number this is, and -7 and y. Okay, so we know that this here is -2, and we know that this here is 1. So we can set up an algebra equation to solve for our x and then our y. So we have -5 plus x over 2 equals -2. So right, this is saying, and then we can solve that. This is saying, right, if I divide by 2, here I get -2. So to undo that, we're trying to get x alone. right, we would multiply by 2 to get rid of that. So this would be negative 5 plus x equals, right, these 2's cancel. Negative 2 times 2 is negative 4. And then let's move this up a little bit. And then this is an algebra problem. I'm going to make these, this is called railroad tracks, just to separate our equation. And then we want to get x alone. So we want to undo minus 5 or negative 5. To undo minusing 5, right, we would add 5. So since we're adding 5 to this side, we're going to add 5 to this side of the tracks, right? These go to 0, so we have our x. And then negative 4 plus 5 is 1. Okay, so then x is 1. And then we're going to do this again for this here for the y. This says 7 plus y over 2 equals 1. We want to get y alone, so we're going to undo this divide by 2 by doing the opposite and multiply by 2 on both sides. Here's my railroad tracks. This cancels. 7 plus y equals 1 times 2 is 2. To undo, this is a positive 7, so we want to get rid of that. We want to subtract 7 from that side, subtract 7 from this side. We get y equals negative 5. So our answer is 1, negative 5. So that's a little harder. That's a little bit more algebra in there. So try this one on your own. Here, the midpoint of AB has coordinates 4, negative 9, and then they give the midpoint. They give you coordinates of the midpoint, one of the endpoints, and then try to find the coordinate of the other endpoint. So push pause, try this on your own, and then check back for the solution. Okay, so here's the solution. Hopefully you got 11, negative 13. Push pause and look at my solution if you didn't, or come to class with questions. Okay, last slide, the distance formula. So the distance formula is going to give the distance between 2 points on a coordinate plane. If we have one endpoint at here and the other endpoint, we'll call the first endpoint x1, y1, and we'll call the second endpoint x2, y2. The distance is going to be this length here. Right, this length here is the difference between x2 and x1, so x2 minus x1. This distance here is the distance between y2 and y1. Did I say distance? Yeah, the difference. Right, so, and then this is a right triangle, so we can just put the Pythagorean theorem, right? A squared plus b squared equals d squared, and then take the square root of both sides. That's how you formulate that. But this is the distance formula. D equals the difference between our x coordinates squared plus the difference between our y coordinates squared, and then you take the square root of that. So let's see this in action. Here we have 2 endpoints, and it says to find the distance. So let's put our... I think the best way to do this is to first label them. So decide that this is going to be, let's call u my 1. So this is my x1 and this is my y1. And then for v, this is going to be my x2 and my y2. That way it'll be easier to plug into the formula. Right, so if we have, this is the square root of the difference between my x's. So x2, that's going to be my 4. x1 is my negative 7. So this is, this is minus negative 7 squared. And then y2 is negative 3. y1 is 5, so minus 5 squared. Okay, so setting up is one of the hard parts, right? The other hard part is going to be now solving it. Remember PEMDAS. We're going to start with our parentheses. So this parentheses is negative 7, and we're subtracting a negative 7. So remember, when you subtract a negative 7, you're in essence adding. So let's just change that to be adding. So 7 plus 4 is 11. So this is going to be 11 squared. And then negative 3 minus 5 is going to be negative 8. That's going to be negative 8 squared. Okay, so we're simplifying. 11 squared is 121. Now, careful here, negative 8 squared, since this negative 8 is in parentheses, this is going to be positive, right? Because this is negative 8 times negative 8. So this is going to be positive 64. Squaring always gives you a positive number. So this is positive 64, and then the square root of 121 plus 64 is 185. And this is to round to the nearest tenth. So I do not expect you to be able to do this in your head. You should be able to use a calculator or Desmos, and just do in your calculator the square root of 185, and you get 13.60147, blah, 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 going on, but rounding to the nearest tenth, right, let's say this equals about 13.60147, dot, 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 right, and to the nearest tenth is going to be this digit here. So this is going to be 13.6. Let's see, the next one is digit is 0, so we don't have to change this. This will stay at 6. Okay, so our answer is 13.6. Okay, and now try this one on your own. This has endpoints, so I'm giving you 2 endpoints. Find the distance between S and R. And again, just note that, right, this SR without a line on top, that means the length of SR, the distance. So try the distance formula on your own and then check back for solutions, and then we'll be done. All right, here's the solution. Hopefully you got 15.8 when you rounded it. So push pause and take a look at my solution to check your answers. And then the homework for this section is below.